All right, okay, so we're on to inverse functions. So inverse functions, if you see something that looks like this, with a power of -1, then what you were doing is finding the inverse function. Now, I'm going to mention something now that's not meant to confuse you, but later on you'll understand why I'm mentioning it. Now, later on we're going to talk about differentiation, and that is shown by f-x, okay? So often people get the two mixed up. Okay, so please make sure that you are aware when it's a -1, then we're finding the inverse. Right. Finding inverse functions, I'm hoping you're going to think is super easy. It's just remembering a process and then repeating it each time. So, if you're given the function as fx, or whatever, gx, dx, whatever, and so you're given a function, all you have to do is rewrite it as y equals. Okay, so that's our first step. So the first step for here would be y equals, where's 4x plus 2. We just change it from an fx to a y. Okay, so that's our first step. The second step is wherever you see an x, you're now going to write y, and wherever you see a y, you're going to write the letter x. So the second step would be to say x equals 4y plus 2. So literally, you're just switching the letters. But that's for any location. So if x is in multiple places, then you're going to put y in multiple places. Okay? Now you're going to rearrange and make y the subject. Okay? So this is the hard stuff. Y was the subject, but then we changed our letters around, and now we have to rearrange it. Okay? So when we rearrange this, how do we rearrange this bad boy? Oh, okay, so we're going to take away 2 from both sides. Oh, Lord above. What's going on here? We take away 2 from both sides, so we've got x minus 2 equals 4y. So x divided by 4 equals y. That means our inverse function is x minus 2 over 4.
X minus 2.
Oh,
That's the inverse?
yeah.
And then you'd have to find
That's it, that's it. Full stop.
X minus 1.
Yeah, x minus 1.
Alright. What's the point? Like,
Okay, so this is where, and I sometimes talk about it depending on people ask questions. If people are happy just to go through the motions, then I often don't try and confuse people. Essentially, an inverse function is just where the x and the y values are switched. So if I were to draw a function, so this is my original function, this is fx, it happens to be a straight line. Well, that's a really rubbish choice, bless you. I'm actually going to do that. Okay, that's my function. It doesn't matter what it is, that's my function. If I'm trying to find my inverse function, as you can see, we switch the x and the y values, yes? That means that any coordinates that would be on here, so say if that was the example, for example, that's the coordinate 4, 1, on my inverse function, it would go through the coordinates 1, 4, because the x and the y values were switched. Now what that means is if we were to try and sketch this, how would I label this line? Who remembers the equation of the diagonal line that goes through it? Yep. That's for most straight lines, but this diagonal one through here has a special one.
Y equals F?
Yes, it's the line y equals x. Oh my goodness. So that diagonal line is the line y equals x, because it goes through 1, 1, 2, 2, 3, 3, 4, 4. Makes sense? Because the y value is equal to the x value. So if we were finding the inverse function, it would be a reflection in that line, because all of the x values have become the y values, and all of the y values have become the x values. Well, now I have to try and draw it. Okay, so this would be f minus 1 x. So that's what's happening when we're finding inverse functions. Okay, we're finding the reflection in this line, and we're switching the x and the y values. Okay? this next example, so we do the same method. So we write y equals x over 3 plus 4. What's the next thing we do? Switch the x for y. So we're going to write x equals y over 3 plus 4. Perhaps I should have chosen a more challenging example. Now we need to rearrange to make y the subject. What's the first thing we need to move? Or get rid of?
4.
Yep, so we're going to have x minus 4 equals y over 3.
Did you expand after the 3 years?
No, so now our final step is obviously multiply, but we need to show it with brackets. Okay, please don't show without brackets. And no, you don't have to expand it, you can if you wish. Okay, so you have a choice here that if you're remembering to multiply both of them by it, you could have 3x minus 12 equals y, but you could leave it as this one here. Okay, so that means that, oh, this is g, I need to write it again. So g minus 1x is 3 bracket x minus 1. Pretty straightforward, yes? Yes.
Is x plus 3 x over 3 plus 4 the same as x plus 4 over 3?
No. And that's the key difference, deciding on which thing you move first. So if you had x plus 4 all over 3, the fact that the division sign comes underneath it all implies that there's a bracket around it. So remembering that you're doing bed maths backwards means that you can deal with the multiplication before you deal with that bracket. So even though the bracket's not written there, it implies that there is. Okay? Okay, the function fx is defined as fx is blah blah, where x is a positive real number. Find the inverse function. Oh, yes, Hannah, sorry.
How do you know that the question is inverse? Because it doesn't say the minus. It says find the inverse function.
It just says at the top in bold. Normally it would be clear. Like, so for example, these things here, it says find the inverse function. Okay? Or if it says just find f minus 1, if you see a minus 1 anywhere, you're going to have to find the inverse function. Alright, so here we go. So we've got y equals 3x squared plus 7. Next step is, so we write x equals 3y squared plus 7. Rearranging to make y the subject, make sure you're moving things or undoing them in the correct order. So we've got to take away 7 first of all, yes? So x minus 7 equals 3y squared. Then what are we going to do? Divide by 3. So we've got x minus 7 over 3 equals y squared. Then how do we undo the squaring? Square root. So we've got the square root of x minus 7 over 3. Now note please that my square root sign very clearly goes over both the top and the bottom. When you're doing these, please make sure that yours looks the same, or make sure you have a bracket around it like that. Okay, so if you're one of these fast writers, Natanya, I'm going to pick on you here. So if you're one of these faster people and they just get it down, to finish on, move on, make sure you've got a bracket around it to show it's nice and clear. Okay. What else should we be including these days?
Plus or minus.
The plus or minus when we're square rooting. Okay, so our f minus 1x is plus or minus the square root of x minus 7 over 3. Alright, next one. fx is defined as 4x plus 3. It's a nice straightforward one. So first of all, it says just find f5. Okay, so this is going back to what we were doing early days. How do I find f5? What do I have to do? Substitute 5. Yep. So we've got 4 bracket 5 plus 3. So that's 23. Nice. Easy. Now this next one says we need to find f minus 1, 35. So we first of all need to find an expression for f minus 1. Okay? So for part B, our first step is to find f minus 1x, is my suggestion. Okay? So to do that, we're going to write y equals 4x plus 3. X x equals 4y plus 3. Do some handy dandy rearranging. And so we know that our f minus 1x is x minus 3 all over 4. So if they've asked us to find f minus 1 of 35, what are we going to do now? Exactly. So we've got 35, subtract 3, all divided by 4, which is 32 over 4, which is 80. Yeah. Okay. So that one, I guess, Hannah, they haven't said find the inverse function, but as soon as you see the minus 1, we knew that we had to find the expression for it somehow. Okay. And next one, the function h is defined as blah blah. Solve the equation h minus 1x equals 6x. Okay, so we need to solve an equation, but we've talked about the inverse function. So we need to find an expression for that first of all. So we've got y equals x minus 5 over 2. X equals y minus 5 over 2. So here, what's the first thing we need to get rid of or undo? The divide by 2. Good. So we're going to multiply by 2. So we've got 2x equals y minus 5. And then 2x plus 5 equals y. So our function h minus 1x is equal to 2x plus 5.
Wait.
I'm waiting.
Could it be 2 bracket x plus 5 bracket?
No. Because you undid things the wrong order, I think.
So you have to do.
Yeah, because remember, so that's what they was asking me. Are they different? So because my line goes all the way underneath it, the first thing I need to undo is the divide by 2. So that becomes 2x. And then we add the 5. Okay, so it makes a big difference. So that's my expression for h minus 1x. Now they've said we need to solve the equation h minus 1x equals 6x. So what do we suggest that we might do now? Exactly that. Did everyone hear?
No.
So we're going to write 2x plus 5 equals 6x. Because this was our expression for h minus 1x. So that's going to go in place of that. And we're just going to write it equal to 6x. Does that make sense?
And that's it?
What, and then we have to solve it. Sorry. Now I can see I've got more x's on this side than this side, so I'm actually going to take away 2x from both sides. So I've got 5 is equal to 4x. And then I need to get x on its own, so I need to divide by 4. So x is equal to 5 over 4.
What if we minus 5? Because switching it from 0 to 6.
Well, no, so I chose to isolate on the right-hand side than the left, because I had more x's on that side. Yeah? Everyone happy with that?
That's it.
Yeah, that's
Wait,
it.
can you
We've solved it. Okay, we'll talk about composites later. Let's try some inverse work.